This is part 2 of chapter 10.1. We've just finished some of the language of hypothesis testing. We introduced two new terms, a few new terms, hypothesis testing, but important terms we introduced was the null hypothesis. So you're going to make sure you use that language, null hypothesis. And then the other one was the alternative hypothesis. We introduced that terminology. Now, there are going to be three ways to set up the null and alternative hypothesis. There's three different types of tests we run. Those terms are called two-tailed tests, left-tailed tests, right-tailed tests. And from our PowerPoint, you could see, I'll write this down, but I want to show you at least from the PowerPoint so you can see it. One of the first ways is through what's called a two-tailed test, and I'll explain something of that. This has to be related to the normal curve. There's two tails, right? And so that's one way to do it. A second way is through a left tail test. And then the third way is going to be with a right tail test. And so looking at what we want you to put in here for a two-tailed test, list the ways. On a two-tailed test, you actually, when we do a hypothesis test, your first thing is to write your hypothesis. And so you're going to say H sub 0, the null hypothesis, is going to be some parameter equal to some value. And the alternative hypothesis is going to be that parameter. And in this case, that could be proportion or mean. And you're going to say this is not equal to some value. That's the first type of test. The next one is a left tail test. And what we say is the parameter is equal to some value. And then the alternative, right, that there's something, a statement that we're trying to find evidence to support. In this case, it's going to be the parameter is less than some value. And then the third way is through a right tail test. The null hypothesis would be some parameter, which is proportion or mean, population proportion or mean, is equal to some value. And the alternative is going to be a right tail test. Parameter is greater than some value. And so that's what you're going to be following to write and do hypothesis tests. And so this idea of the null hypothesis is a statement of status quo, no difference, and always contains a statement of equality. Very important. Whenever we write the null hypothesis, it always contains a statement of equality, means it uses the equal sign in each of those three statements. That will never change. The null hypothesis is assumed to be true until we have evidence to the contrary. We seek evidence that supports the statement in the alternative hypothesis. So, for example, in these examples here, in 2008, 62% of adults regularly volunteered. A researcher believes that this percentage is different today. So, if we were to do a hypothesis test on that, we would say the null hypothesis is that the proportion of Americans is equal to 0.62. The alternative is that it's different, so we would say that P is not equal to 0.62. That was, again, this assumption, believes that the percentage is different, and that's why we use the not equals. In another case, according to a study published in March 2016, the length of the phone call, so we would say null hypothesis. And so what we would say in this case, the mean is equal to 3.25. The researcher believes the mean length has increased. And so the alternative hypothesis is going to be the mean is, means that it has increased is greater than 3.25. Okay, so let's go ahead and look at another example of writing null hypothesis an alternative hypothesis and just decide whether it's a two-tailed, left-tailed, right-tailed test. Medical pharmacy company has developed a new antibiotic. 2% of children taking medications experience headaches as a side effect. The researcher for the FDA wants to know if this percentage of the new antibiotic taking the new antibiotic has a side effect that is more than, and so the null hypothesis is that there's no effect, nothing's happening. So what we would say that P is equal to 0.02. The alternative is that P is greater than 0.02 using this language here. And this would be a right-tailed test. Again, P is greater than, so that would be to the right of a normal curve. The greater than is, we're talking about a right tail. We also go back to our notes here. When it's a greater than, it's a right-tailed test. Next example, the blue book of a used car is $56,130. Grant wonders if the mean price of the used car in the Miami metropolitan area is different. If it is different, that's the key. So here in this case, we have the null hypothesis is that the mean is equal to 56130. The alternative here is different from this number, and so the mean is not 56,130. This would be a two-tailed test.